Hello everyone! Welcome to my channel. This is me, NHB Orion Dayaganon from BSED Mathematics 1B. So in today's vlog, I want to share a little bit about myself and my passion for mathematics. So let's get started. Ever since I was a kid, I've been fascinated by numbers and patterns. And there's something incredibly satisfying about solving a complex problem and discovering the underlying logic behind it. And it's like cracking a code or solving a puzzle. For me, math isn't just about numbers and equations, but it's also a way of thinking and a language that helps us to understand the world around us, from the symmetry of the nature to the technology that we use every day. So for me, math is everywhere. One of my favorite areas about mathematics is the trigonometry and the geometry because it's fun and I enjoy solving problems about it. And it's amazing how these concepts can be applied to the real life situations and make a tangible impact. The purpose of this video is that I will be going to discuss about the derivation of double angle identities, particularly the sine and the cosine, and provide an example demonstrating about the application formula of the identities and explain each step of the solution process. If you're interested in learning about this topic, make sure to hit the subscribe button and join me on this exciting journey. To get the double angle formula per sine, we use the sum and difference formula per sine, which is sine alpha plus beta is equals to sine alpha cosine beta plus cosine alpha sine beta. We replace the alpha and beta as theta, so sine theta plus theta, which is the same as sine 2 theta. So sine theta cosine theta plus cosine theta sine theta. Sine cosine plus sine cosine is equals to 2 sine theta cosine theta. And now we have the formula for double angle identity per sine. The double angle identity formula for cosine is derived in the same manner. Cosine alpha plus beta is equals to cosine alpha times cosine beta minus sine alpha times sine beta. We replace the alpha and beta as theta, so cosine theta plus theta, which is the same as cosine 2 theta. So cosine theta times cosine theta minus sine theta times sine theta. Cosine theta times cosine theta is equals to cosine squared theta minus sine theta times sine theta is equals to sine squared theta. And now we have the double angle identity formula for cosine. We can also rewrite the formula like this. And now, by using the Pythagorean identities, we know that cosine squared theta is equals to 1 minus sine squared theta. So, we replace the cosine squared theta like this: 1 minus sine squared theta minus sine squared theta. And it will become like this. Cosine 2 theta is equals to 1 minus 2 sine squared theta. We can also rewrite the formula like this. By using again the Pythagorean identities, we know that the sine squared theta is equals to 1 minus cosine squared theta. So we replace the sine squared theta into 1 minus cosine squared theta. And it will become like this. Cosine 2 theta is equals to 2 cosine squared theta minus 1. And now, we have two alternative formulas for the double angle identity formula for cosine. And now, we have here an example. Tangent theta is equals to 4 over 3. The theta is between 0 and 90 degrees. First, we will draw a triangle. And note that the theta here is in quadrant 1. So we have here the 4 and the 3. The 4 is the opposite side and the 3 is the adjacent one. And now, we have to find the hypotenuse. Using the Pythagorean theorem, c squared is equals a squared plus b squared. So, c squared is equals 3 squared plus 4 squared. So, 3 squared is 9 plus 4 squared is 16. So, 9 plus 16 is equals to 25. And square the both sides. So we have 5 as the hypotenuse. And now, we will find the value of sine. We know that the sine is opposite over the hypotenuse. So we have 4 over 5. We will also find the value of cosine, and we know that the cosine is adjacent over the hypotenuse. So, we have here the 3 over 5. And now, we're going to find the value of sine 2 theta. We will use the formula 2 sine theta times cosine theta. Now, we have the value for sine, which is the 4 over 5. And the value of cosine, which is the 3 over 5. So, 2 times 4 times 3 is equals to 24. And 5 times 5 is equals to 25. So we have here the value of sine 2 theta, which is 24 over 25. And now, we're going to find the value of cosine 2 theta using the formula cosine squared theta minus sine squared theta. We have the value for cosine, which is 3 over 5 squared minus 4 over 5 squared is equals to 3 squared is 9 and 5 squared is 25 minus 4 squared is 16 over 5 squared is 25. So now, since they have the same denominator, we combined it. 9 minus 16 over 25 is equals to negative 7 over 25. And we have now the value of cosine 2 theta. If we find the value of tangent 2 theta, we know that using the quotient identity, tangent is equals to sine over cosine. So now we have the sine 2 theta over cosine 2 theta. Since we have the value of sine 2 theta and cosine 2 theta, we just distribute it. So we have 24 over 25 all over negative 7 over 25. So we will just cross out the 25, and now we have the tangent 2 theta, negative 24 over 7. Since trigonometry can solve problems in the actual world, it is important in many different fields. Trigonometry, for instance, is used in astronomy to measure the angles between celestial bodies, calculate their trajectories, and measure the distances to stars and planets. This example shows how trigonometry is essential to tackling challenging problems in a variety of academic fields, highlighting its practical applications and significance. And that wraps up our tutorial on the derivation of double angle identities in their real-world applications in trigonometry. Understanding these principles not only strengthens your math skills but also opens up a deeper appreciation for how mathematics describes the world around us. Keep exploring the fascinating world of mathematics, and I'll see you again in the next video. Thank you so much for watching!